Okay, let's take a look at the last problem in this session. This problem is asking us to find V12 using source exchange. So we can see here that V12 is these two. And we have two separate sources. We have a current and a voltage source. Now, working with both of these could be pretty difficult, especially considering we could potentially make mistakes with a nodal analysis. So the source exchange, if you remember at the very beginning of the semester, we were talking about if we can find a circuit that had pure parallel in it, then what we could do is we could combine these two together by adding them together, because what's effectively happening is you're taking the current from here, some's going to go that way, some's going to go that way, and then this will come this way, some will go this way, and then some will go that way. So you're just adding the same current just from a different direction. So you can really just take this and do something like this. It's I1 plus I2. And then now that way it's still the same amount of current being added into the circuit. Okay, so that's just a general concept that we went over at the very beginning of the semester. But let me clean this up and we will look at the context of this problem. Okay, so we see that we have already this in parallel with each other, but this is not. So what we can do is now we see that this is going to be in series with the voltage source, so we can change that into the current source using the source exchange. Let me go redraw this. So this will be 2 amps. This will be 30. One, two. This will be 60. And now this I will be equal to V over R, which will be 30 or 60, which will give us 0.5. Okay, and if we look at these branches now, we see that 1, 2, 3, 4, and 5 are all in parallel with each other, which is really good for us, which means that we can go ahead and add the two current sources together and create one more circuit. So we can do this. We will come over here and do 2.5 amps. $30 and then 60. Okay, and then all we need to do is to determine the voltage across these is determine the current that goes through either one of these resistors, and we'll need to do a current division for that. So we'll call this one I1, this one would be I2. So if we did I1, that would be equal to R parallel over R30 times I of S. Well, we got to find R parallel, and the R parallel is going to come from these two. So R parallel is going to be 30 times 60 over 30 plus 60. and that'll give us 20. So therefore, I1 will be equal to 20 over 30 times 2.5 amps, and this will give us 1.67 amps. So the voltage across the 30 ohm resistor is going to be 1.67 amps times 30 ohms, and that should give us 50 volts for V of 30, and V of 30 is equal to V1, 2. So therefore V12 is also equal to 50 volts. And as a quick check, if we wanted to check I2, same process, 20 over 60 times 2.5, that would give us, let's see, 2.5, .833 amps. Therefore, V of 60 would be equal to 0.833 amps times 60, which would also give you 50 volts, which is also equal to V12. So just some useful ways for you to use source exchange.